Okay, today we're going to be talking about derivatives. Okay, we're just going to start talking about derivatives and the tangent line problem. So, derivatives is pretty much the main topic of first semester calculus. Okay, so what is a derivative? Well, if you look at a line from algebra, a line has a slope. And that slope is always the same. So you can look at a line and you can say, hey, the slope of this line is 3. And so that slope is the same everywhere. But if you look at a curve like this parabola right here, the slope is obviously not the same everywhere. Here it's negative, here it's 0, here it's positive. And it's getting steeper. The further you go this way, the slope gets steeper and steeper. Okay, so how do you find the slope of this thing? Well, the answer is you don't find the slope of this curve. You find a slope, you find an equation that will tell you the slope at any particular point on this curve. Okay, and we start out considering the tangent line. Now, if you remember, a tangent is a line that touches a curve at exactly one point. Okay, so the slope of that tangent line is the slope of the curve at that point. The problem is it's difficult to calculate the slope of that tangent line. So what we do is instead of finding the slope of a tangent line, we find the slope of a secant. Okay, what is a secant line? A secant line is a line that passes through a curve at 2 points. So what you do is, here's the point I want to know the slope at. I pick some other point on the curve, okay, that is somewhat nearby this point P. Okay, now the difference between the x-coordinate here and the x-coordinate here is called delta x. Delta means change in. Okay, so here's my change in x, and then this would be my change in the y-coordinates. Okay, and my goal is to take these 2 points and bring them closer and closer together, and the slope of that secant line, as this point gets closer to this one, will become closer and closer and closer to the tangent slope. Okay, so make sure you understand what these are. Here, if I take, this is the point C right here, and if I plug C into the equation, then this is f of C. This is the point C plus delta x. So the y-coordinate here would be f of C plus delta x. Okay, now, if you think back with lines, the slope of the line, here's the equation for the slope of a line. M equals y2 minus y1 over x2 minus x1. If I use that formula on these 2 points, okay, I can take y2 minus y1, so f of c plus delta x minus f of c, divided by x2 minus x1, so c plus delta x minus c. Now what happens here is the c minus c cancels out, and I'm just left with delta x on the bottom. Okay, so this formula right here, the slope of the secant, that's what this means, is f of c plus delta x minus f of c divided by delta x. That's called the difference quotient. The numerator is the change in y, the denominator is the change in x. Now by choosing my points closer and closer to P, the slope of the secant line gets closer and closer to the slope of the tangent line. And what we find out is that the limit as delta x goes to 0 of delta y divided by delta x is equal to the limit as delta x goes to 0 of f of c plus delta x minus f of c over delta x, and that comes out to be m, which is the slope. Okay, so let's look at this one here. Find the slope of the graph. F of x is 2x minus 3 when c is 2. So here's our formula. We're going to find the limit as delta x goes to 0 of f of 2 plus delta x minus f of 2 divided by delta x. Okay. So what do? I take 2 plus delta x and I put it into here. Okay. So this is going in here, and I get 2 times 2 plus delta x minus 3 minus f of 2. So I'm going to take the 2 and I'm going to plug it in here. That goes right there. Divided by delta x. Okay, so if I distribute this in here, I get 4 plus 2 delta x. Should probably have another parentheses on this. Okay, and then over here, I get negative 3 minus whatever this is. Well, that's 4 minus 3, which is 1, divided by delta x. Now, this is 4 minus 3 minus 1. That's just 0. So this stuff all cancels out. And I'm left with 2 delta x over delta x. And, of course, now the deltas cancel out, the delta x. And I'm left with the limit as delta x goes to 0 of 2, which is just 2. Okay, and if you look at this, this is a line, okay? And the slope is right there. The slope is 2. So by using the definition of the derivative, we end up with the slope. Now, on a line, that's easier to just look at it and say this is the slope, but on a curve, that's not the case. Okay, so we're going to find the slopes of the tangent lines to the graph of f of x equals x squared plus 1 at the point 0, 1 and at negative 1, 2. So I have 2 things to do here. I'm going to find the slope right here, and I'm going to find the slope right here. Okay, so we're going to go back to the definition here of what it is to be a derivative. Okay. So the limit as delta x goes to 0 of f of c plus delta x minus f of c divided by delta x. So I'm going to take this stuff right here, and I'm going to plug it into this equation. So that stuff goes in here, and I get c plus delta x squared plus 1 minus, now I'm going to take c and plug it into there, and I'm going to get c squared plus 1 divided by delta x. Now I'm going to FOIL this stuff. Okay, remember FOIL? First, outside, inside, last. So c times c is c squared. Outside times, the outside numbers would be c times delta x, and the inside numbers would also be c times delta x. So I'm going to get 2c delta x. And then I'm going to get plus delta x squared. Those are going to be the last ones. Plus 1. And then this is, I'm going to distribute the minus sign in here. So this is going to be minus c squared minus 1. And now it's just a little bit of algebra. So if you look here, I got a c squared and a minus c squared. That goes away. And I'm left with this. The limit as delta x goes to 0 of 2c delta x, that's this, plus delta x squared divided by delta. Now, both of these have a delta, so again, I can cancel. This is going to cancel this one, and it's going to cancel one of those 2 things. So I'm going to get, okay, so I took a step here and I factored out the delta x, and then I canceled it. Okay, now, what happens as delta x goes to 0? Well, as this goes to 0, that disappears. I'm just left with 2c. So the slope of this thing is going to be 2c. So what that means is I'm going to take the x coordinate, whatever that is, where I want to find the slope. So like right here, I wanted to find the slope at -1, I'm just going to take -1, and I'm going to take 2 times -1 is going to be -2. That's going to be the slope right there. And then I also wanted to know at 0, which is right here, so I would go 2 times 0, and that's 0. If I wanted the slope at 2, I could plug 2 in there. 2 times 2 would be, the slope would be 4. So the slope at any point C, f of C on the graph of f is m equals 2c. So therefore at the point 0, 1, the slope is 0. And at -1, 2, the slope is -2. Okay. Now, of course, there's always weird cases. So what about a tangent line to a curve when the tangent line is a vertical line? So if that's the case, when I do the slope formula here, my derivative is going to be infinity, or it's going to be negative infinity. Okay, so this has a positive slope. It's not very big, but it's getting bigger and bigger and bigger and bigger and bigger, and now it's infinite. And then it's getting smaller and smaller and smaller and smaller and smaller, but it's still positive. Definition of the derivative of a function. The derivative of f at x. This is read f prime of x, or you can just read it as the derivative. This is a symbol for the derivative. There's actually about 4 of them. The derivative of x is the limit as delta x goes to 0 of f of c plus delta x minus f of c over delta x, provided that the limit exists. For all x for which this limit exists, f prime is a function of x. Okay, this is tested primarily on the multiple choice part of the AP exam. This is also called the instantaneous rate of change. Okay, so remember, the slope is how much something is changing. The slope is also your rate of change in a line. So on a curve, your derivative, the answer to your derivative, is the instantaneous rate of change. So if we look back at this one, the rate of change here is -2, but the rate of change here is 0. And the rate of change over here at 2 was 4. So the rate of change changes. Okay, so here's different notations that you will see for derivatives. F prime of x, we'll use that one a lot. dy dx, that's another way to write it. This is actually more useful, I think, when you're doing differential equations. Sometimes it's called y prime. This is when you're using function notation. This is when you're using like y equals 2x plus 3, then y prime would be the derivative. The derivative with respect to x of f of x is another way to write it. And this is the same thing over here, although I hardly ever use this. Okay? Find the derivative of f of x equals x cubed plus 2x using the definition of the derivative. So it's always a good idea to write down your formula. Okay, so my derivative is going to be f of c plus delta x minus f of c over delta x. Okay, so I'm going to take c plus delta x and plug it in here. So f prime of x is going to be c plus delta x cubed plus 2 times c plus delta x minus f of c all over delta x. Okay, on this one, since we don't have a particular c that we're going to use, I'm going to go ahead and just leave x in all these places because it's just going to be a general equation. Okay, so f prime of x. Now I need to cube this. Okay, you can use the binomial theorem or you can do it the long way. So x plus delta x times x plus delta x is going to be, if I FOIL that, it's going to be x squared plus 2 delta x plus delta x squared. And then I take that times x plus delta x. So that's going to be delta x cubed plus, let's see, that's going to be 2 delta x squared plus x squared delta x. And then I multiply all this by x. So this is going to be x delta x squared plus 2 delta x squared, oops, and x cubed. So I should get x cubed plus 3 delta x squareds plus 3 got my x's here wrong. Okay, I ran into a little problem here because I didn't FOIL this right. So let's go back and relook at this. We got x times x is x squared. This is x delta x, and x delta x makes 2x delta x squared. And then times x delta x. So this is delta x cubed. This is, let's just do this over with. Okay, so delta x cubed plus 2x delta x squared plus x squared delta x. That's the first line. And the second line is going to be x delta x squared. That's these two. These two is going to be 2x squared delta x, and then x times x is x cubed. There we go. Now we got x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed. Okay, that's all of this. That's a lot. So we'll rewrite it here. Plus, and we'll distribute this, so plus 2x plus 2 delta x minus f of x, which is going to be x cubed plus 2x. All that's going to be over delta x. Now I'm going to start combining like terms. Let's see here. F prime of x. I've got x cubed minus an x cubed, so this is going to cancel. I've got a 2x minus a 2x over here, so that's going to cancel. So this leaves me with 3x squared delta x plus 3x delta x squared plus delta x cubed all over delta x. Now, there's a delta x in each one of these, so I can go ahead and cancel out a delta x in each one of those terms. So this is 3x squared plus 3x delta x plus delta x squared. Now, remember, I'm going to take the limit as delta x goes to 0. So if this goes to 0, this is all 0. This is certainly 0. So I'm left with 3x squared. That is my derivative, 3x squared. So if I wanted to find the slope of this at the point 1, all I would have to do is find the derivative, plug in 1, and that would be 3. The slope would be 3 at 1. The slope at 0, I plug in 0, I get 0. The slope at 2 would be 2 squared would be 4 times 3 is 12. This thing gets steep super fast. Okay, use the derivative to find the slope at a point. So find f prime of x, for f of x is the square root of x. Then find the slopes of the graph of f at the points 1, 1 and 4, 2. Discuss the behavior of f at 0, 0. Okay, so we have to find the derivative here. So f prime of x is going to be f of x plus, oh, that's terrible, x plus delta x minus f of x all over delta x. So I'm going to have square root of x plus delta x minus f of x. In that case, f of x is going to be the square root of x all over delta x. Okay, so on this one, I've got this weird thing. I think what I'm going to do is I'm going to rationalize this. So I'm going to multiply it by the square root of x plus delta x plus the square root of x all over the square root of x plus delta x plus the square root of x. Remember, that has a value of 1, so I don't change this at all. So what do I get when I do this? Well, this times this is just x plus delta x. Remember, the whole point of rationalizing is that this and this, the outside and the inside, are opposites. They cancel each other out. And then last would be negative times a positive is a negative. And that's just going to be x. Square root of x times square root of x is x. And then on the bottom, I'm going to get delta x times the square root of x plus delta x plus the square root of x. Okay, so those cancel out. This is going to cancel with this because all I have is a delta x left on the top and the bottom. So those are going to cancel out, and I'm going to get 1 over the square root of x plus delta x plus x, or square root of x. Now, remember that we're taking the limit of this. We want the limit as delta x goes to 0. So as this goes to 0, this just becomes square root of x plus the square root of x. So this is 1 over 2 times the square root of x. So there's my slope. Now, if I want to find the slope at what is f prime of 1, I just plug 1 in there. The slope is 1/2. If I want to know 4, f prime of 4 is going to be Square root of 4 is 2. 2 times 2 is 4, so that's 1/4. And what about at 0? So if I find f prime of 0, that's a problem because I get 0 in the denominator, and I can't do that. So if you look at the graph, what the graph looks like is the graph looks like this. Okay, so at 0, this thing ends right there. It doesn't really have a slope there. You could put a tangent line through there any way, well, any way you wanted down this way. And so there is no slope at 0. I think we're going to skip this example for now. I guess we should probably do it. So we would find y prime. Remember, it's going to be f of, in this case, t plus delta t minus f of t divided by delta t. I used t this time because there was a t in the denominator. Okay, so this is going to be 2 divided by t plus delta t minus 2 over t divided by delta t. Now I've got some algebra to do here. I really need a common denominator, so I'm going to multiply this by t plus delta t over t plus delta t. And I'm going to multiply this by t over t. So then this is going to be 2t minus 2 times t plus delta t over the bottom of this whole thing is going to be t times t plus delta t all over delta t. I can distribute my -2 in there. So it's going to be 2t minus 2t minus delta t, or 2 delta t, sorry, divided by this stuff. Now, of course, these cancel. It's going to be the limit as delta t goes to 0 of -2 delta t over t times t plus delta t. Okay, what happens as that goes to 0? Well, this just goes to t, so this is t squared on the bottom. And this goes to 0, so that ends up being 0 on the top. And so this limit comes out to be, that's not right. Okay, made an error here because I forgot something. So we're going to go back, scratch this, because what I forgot was this delta t is still here. Okay. So what do I get now? I get y prime is -2 delta t divided by t times t plus delta t. Now this is just t delta t over 1, so I'm dividing two fractions, so I'm going to go ahead and invert that and multiply. And now my delta t's cancel out. And I get y prime is going to be -2 over t times t plus delta t. Much better. So now when we take the limit as delta t goes to 0, this goes to 0. This becomes t times t, which is t squared, and the top is -2. So there is my derivative, and I can find that at any point that I want by just plugging a number in for t. Okay, differentiability and continuity. The derivative of f at c is f prime of c is the limit as x goes to c of x minus f of c over x minus c. So we've already talked about that. Now, if there is a limit from the positive side and the negative side, if there's a derivative of f at the point f of c, then there must be a limit from both the positive and the negative side. When a function is not continuous at x equals c, it is also not differentiable at c. So if I have any kind of graph that is discontinuous, so maybe I've got something like this, okay, this is not differentiable here. It might be differentiable over here, it might be differentiable over here, but it is not differentiable right there. It's also not continuous. Although it is true that differentiability implies continuity, the converse, continuity implies differentiability, is not true. Okay? So if something is differentiable, it is continuous, but if it's continuous, it's not necessarily differentiable. So here we're going to look at an absolute value. Okay, it's continuous at the point 2. Okay, but that's where you get this sharp curve right here. Now, if you think about it, if it's differentiable, then you can figure out the slope there. But there's an awful lot of slopes that this thing could have at that point, going through that point right there. There's only one that it's going to have here and one over here, because these are basically lines. So you might have you got a slope of -1 here, and you got a slope of +1 here. But what do you have at 2? You can't really do anything there. So it is not differentiable at 2. Okay, the function f of x is the cube root of x is continuous at x equals 0. Consider the limit as x goes to 0 of the cube root of x. Okay, so we're going to go through we want f prime of x. Okay, so that would be f of x plus delta x minus f of x all over delta x. So this would be the cube root of x plus delta x minus the cube root of x all over delta x. Okay, so let's look at this a different way. We don't need to do this because we actually have a point. So what we can do is we can take the cube root of x minus the cube root of 0, because there's going to be my y coordinates. Because if I plug in 0 in here, I get 0. And I divided the difference in the x coordinates, so that's going to be x minus 0. And so and I want to take the limit of that as x goes to 0. Okay, so this ends up being the limit as x goes to 0 of the cube root of x divided by x. Well, if you remember, another way you could write this would be x to the 1/3 divided by x, and you can subtract the exponents, so this is 1 over x to the 2/3 power. And then I can take the limit as x goes to 0, and if I do that, it's undefined. So you can see that this has a vertical tangent line right there. If f is differentiable at x equals c, then f is continuous at x equals c. And here's your assignment for the day. So go ahead and take a look at those problems, and I'll see you in next class.